Yeah.
That's awesome. Well, I've just started recording, just so you know. I think most of you have been here before. I think Audrey might be the only new one, so I'll kind of skim through my usual intros so you don't have to keep hearing the same thing. I'm Liana. Hello. So as you know, it's a space for job hunters or people just wanting to practice questions live, trying to simulate the interview experience. So we're going to do 3 questions each week. Timed, you know the spiel, and it's definitely not a lecture. So this isn't a space for big, long, deep dives into topics. We're trying to touch a lot of topics and just get practice and focus on the practical side of things. So I recommend jumping on meetup.com to find those deep dive meetups if that's what you're looking for. And I hope it's a space of accountability and where hopefully you can meet people in the same boat as you, trying to go through this wonderful world of job searching. Schedule, again, you guys are all familiar with the schedule, so I'll sort of skip over this. Audrey, just for you, we do about 45 minutes of questions, and then the last 30 minutes is just open for discussion, or you can leave early if you want to. Cool. Same resources as I've presented in previous weeks for using Google Colab. We are going to be doing a Python question today, so it's probably useful to have either your terminal open with Python or a Google or Jupyter notebook open so you can test your function. And then one thing I do want to ask of you is, while I'm curating the questions each week, I really want to, this session is for all of us. So if you can reach out to me on Slack or LinkedIn, wherever you are connected with me. And if you have questions that you come across that you want to work on, please send them. I'm trying to generate a question bank. It's challenging to find good questions with good solutions. And I would like to make these sessions relevant to you. So if there's a question you found difficult or a question you haven't looked at yet, send them to me, and I'm really happy to add them to be one of our questions for the week. So yeah, just reach out to me directly on Slack, and I'll try and get a question bank going so it's more relevant to you. And then I do record these sessions and put them on YouTube so that you can refer back at another time if you miss a session. All of these are linked, so when I post the slides in the Slack group after this session, you'll be able to click on all these links. These are the topics we try and cover. Today we're going to be covering Python, a Python algorithms question. We're also going to be doing a SQL fundamentals question, nice easy one, hopefully easy one. And we're also going to be doing a statistics probability question at the end, as I just mentioned. So any questions, thoughts right now? Have a quick pause moment. No? Cool. All right, so today's SQL one, it's going to look quite basic at the beginning, but it's really just, it's actually a question I got in an interview last week that I had, and I was sort of surprised by the question, but it just tests fundamentals on databases in general and understanding of queries. So question number 1, we won't spend too much time on it because it is a quicker one, but here it is. So given the following schema, which is this schema over here, table A, table B, what would be the output of this query over here? So just two tables, they both have an ID column, and these are the rows, and this is the query over here. So jot down what you think. If you need to ask clarifying questions, please do. But I'll give you a couple of moments to think about it, write it down, or however you want. Okay. I won't spend too long on this. Does anyone want to, maybe not Amanda, anyone want to chime in with what they're thinking on this one?
I have some thoughts, but I don't know if that's correct. So I think it would give like the table A with only 1, 1, 2, maybe, because I haven't really seen like the table with only one thing in it, with only one column, which is ID. So I don't know if that's valid or not.
It is slightly contrived. Do you want to give sort of your thinking as when you say it would return table A with 1, 1, 2, do you want to sort of expand on your thinking of why you're thinking in that way?
Because inner join means the things that are contained in both tables, like at the intersection. So the first, like the things that are in the first row, ID is equal in both tables. Same thing for the second row and the third row, but not for the last 2 rows.
Okay, so are you saying the final query would be one column containing 1, 1, 2?
Yeah.
Okay. Anyone else? Did anyone else have a different solution to that?
Yeah, can I go ahead?
Yeah, sure.
Yeah, I think the matching column is right, 1, 1, 2, but the rest column will be concatenated. So from A and B, whose row or in ID 1, 1, 2 will be automatically added, I think, from B and A.
Okay. And so how many, do you agree with Joyce that the resulting query would have 1 column?
I think the total number of columns will be, the total number of columns in A, either in A and B, the maximum one.
Okay.
I have a different idea.
Yep. Let's hear it.
I believe the result would have 2 columns. One is A.id and the other is B.id. And in terms of contents, I think there will be 4 rows which have 1 and 1, and then 2 rows that have 2 and 2, because I think each row from the first from A, which has 1, should be matched with each of the rows in B, which has 1, and similar for 2, but for 2 we only have 2 rows in A.
So how many rows in total?
6. 4 plus 2.
Okay.
I kind of have different answer. If we see the Venn diagram of inner join, so it consists of what's in the middle, like the common things in both the table.
Yep.
So with that, the data should be 1, 1, 2, and as it says, select A dot star, comma B dot star. So it should have 2 columns, both of ID, 2 columns with same data of 1, 1, 2.
Cool. And Ril, do you agree with Svetlana's assessment of what the rows would be?
Row, she said that 6 rows would be there. I think there would be no.
You think just 1, 1, 2?
Yeah, 1, 1, 2.
Okay, because you're thinking about what's in common with these 2.
Yeah.
Okay.
Yeah.
Any other alternatives, variations, thoughts on this one before we run the query?
I think I agree with Sabrina, because I think for inner join, it just have the common things from table A and join to join. That means like we have 1 in A. The first one would join to the first one in B, and then this same one in A would join to the second one in B. And
right, so like this, and then like this.
Yeah.
Yep. And then this one.
I think, yeah, and then the second one in A, the same logic, and the following items in A.
Yep. So you're saying the same as Svetlana, that each of the one in A joins to both of the ones in B. The
Yeah.
second one in A joins to both the ones in B. This
Mhm.
2 joins to this 2. This 2 joins to this 2. So that's where our 6 rows come in.
Yeah.
Cool. All right. Well, let's run the query. So this one, I'm not sure if anyone's come across SQL Fiddle before, but you can create your own schemas, tables, whatnot. You can play around with it yourself. But we've created the schema over here, and then we run this, which it already was. We can see we've got those, exactly what Svetlana and Juan was saying just then. We do actually have the 6 rows. Sorry, Amanda, that must have been killing you to stay silent.
Inner joins are Cartesian products, right? You're basically taking every combination from both columns.
Exactly. And so this one, while the query, I feel like the query is deceptively simple, but exactly what you just said, what they're really testing in an interview is, do you understand these relationships one-to-one, one-to-many, many-to-one, many-to-many? And in this scenario, like we said, we had this same one, because we're doing the inner join and we're selecting both columns, we are getting the relationship from each one. So I think this is the main takeaway from this question, is understanding these relationships between table databases. So and then on top of that, the types of joins and how does the relationship of your tables, how is your join going to impact that relationship? And it's also the flip side in an interview where they're presenting you with a query and you're explaining your rationale why. So it's one thing to be able to say it's going to have 2 columns and 6 rows, and this is what they are, but can you explain why that is the case? So that was kind of an interesting question. Does anybody have any other thoughts on that, or any other takeaways from that question?
Just a question. Can you go back to the previous slide, Anna?
Yeah.
So if you change the order here, nothing changes, right? If you do from B inner join on A, or if you change the order of IDs, the equality, nothing changes, right?
Inner joins don't depend on the order that the tables are written, only left and right joins really.
Sure.
So yeah, so if you wrote it from B inner join A, it would be the same.
Okay. Then the next question would be, let's say this was a very imbalanced data set where A had like 100 rows and B only had 10 rows. Would the order matter in terms of performance, or regardless of what order you choose, it would be executed at the same time?
It would be executed at the same time, because it always starts with your first table, right? The from, and then has to match it to the second table on where you're putting the on, right? So no matter what, it's going to look at the 100 rows of that table in that column.
Okay.
No matter which order you put it in. So that should not make a difference in performance. There's probably some little caveats to that if it gets more complex than just this quick one, but for the most part, that's not going to make a big difference.
Got it. Okay.
What is the complexity of the matching operation? The naive way to do it would be like number of elements in A times number of elements in B. In theory, one could sort the 2 arrays and get a.
That's what I was trying to get to. Yeah.
Yeah, that's a good point. I'm actually not sure. Amanda, do you know anything about the time complexity on something like this?
For a SQL query, no, this one's so simple. I don't think it's going to be.
Yeah, I might look that up.
Yeah, it sounds like you're trying to compare it to like a Python array and sorting that to get the results.
Well, I'm just imagining that if A has 3 million elements and B has several 100,000, how is that going to scale if there's a lot of duplicates?
I think normally you want to have an index on the field on which you are doing join, and then the search is fast.
Well, and what it looks like they're really trying to give you in this, because notice they've got the little asterisks in the select. So they're going to actually be selecting all of the columns in these tables. They're only showing you the IDs because that's how those tables can connect. But there's probably 9 or 10 additional columns in each of these tables if they were to run it real world, right? Like this might be, A might be sales IDs, and that same one is in this B table, which might be customers. So now you're matching up every time a customer had a sale.
Yeah.
So it's a little bit different than just sorting it. And
Yeah, I'll look into that a little more. Who knew such a simple question would have so many, so many checklists?
That's interesting.
Yeah,
it's the joys of SQL, because you can get the exact same thing 900 different ways. And
I feel like this is the thing with SQL, is that the language itself, you know, syntactically, it's very simple, but that's why it takes years to master, because it is all these, you know, understanding the relationships of these databases, the tables, and on top of that, the actual performance of the operation.
And if you're working in other languages, right, like SQL is just declarative. It just says, get me these from these tables, right? It doesn't tell SQL how to go and do it. Whereas all these other stuff, you're actually saying, I want you to loop through this. I want you to find this. I want you to print out this. But SQL does all that on the background on its own. It'll optimize your queries as much as it can from what you've written.
Yeah. And speaking of, I've got a couple of resources here. Of course, there are tons of resources on this. This question I set up in Fiddle, so I can provide you with the Fiddle link if you want to fiddle around with the one we did today. And then generally, fiddle.com, you can quickly build your own schemas if you're trying to do practice problems or whatever you're trying to do. I've spoken about mode tutorials from basic to advanced, and then some people like just an old-fashioned book. So there's a bunch of good O'Reilly books if you do want to crash course yourself on fundamentals, and there are a bunch that talk about performance. There are a bunch that talk about analytics and doing things like linear regression with SQL, which seems a little, you know.
Don't do it. Don't do it.
So my next question is everyone done on the SQL? Anything else on that one? So next one is a Python one, just your classic algorithmic one. Write a function to return consecutive values from a list into a list of tuples. So you're given just a list of numbers, and we want it to return the start and end point of each consecutive pair. So 1 through to 4 will return the tuple 1 to 4. A single number that isn't in a list of consecutives will be 99 to 99. Start and end will be itself. And then we want the list to be sorted from the smallest to the largest consecutives. So take a couple of minutes, maybe 3 to 5 minutes, unless you yell out and you want less time or more time. And please ask any clarifying questions you might have.
I have questions like the first output is 1,4. So what was the input like?
So this, your function will take an input, a list of numbers,
Okay.
list of integers specifically. So your output here of 1 to 4, it's taking, in the list we have 1, 2, 3, 4. That's your first consecutive group. So we want the tuple to contain the starting point and the ending point. And then the next consecutive is 7, 8. And then 10, 11 will be the start and end. And then 99, 99 is on its own.
Can we assume a lack of duplicates in the array, or should we not make that assumption?
I think for purposes of this exercise, yes. We're going to assume that they appear as consecutive. So you're not going to have 1, 2, 3s over here and 4 here. So they will be in a row. And
I meant that you wouldn't have more than 1, 3, for instance.
Oh, more than 1, 3. I think this problem would actually still work if you did. Do you mean if you had 1, 2, 3, 4, and then 2, 3, 4 or something?
Or if you had 1, 2, 3, 4, 99, 10, 11, 3, 7, 8.
Right. Okay. Yeah. No. So we want we'll identify the consecutives that are together, grouped together. So in that scenario, the 3 would be 3, 3. It would be like the 99.
And does the final list need to be sorted numerically, or does that matter?
Yes, so you'll see the 7, 8 appears at the end, but we want it to appear in the order of the starting digit. It's been about 3 minutes. Would you like a little bit more time? Give you another minute.
I would, yes.
No worries. Okay, I've got my notebook here. We might start as a group together, and we'll, if you haven't finished, you'll probably be finished by the time we work through it. So we'll write this function consecutives, and nums is our list of numbers, list of integers. Anyone want to get started? Don't necessarily have to tell me what the code is, but does anyone want to talk me through the algorithm that they're thinking of how they would approach this question? Just in plain English, doesn't have to be perfect code.
Well, the idea is that you're going to read the numbers sequentially from left to right, and there's going to be two alternatives. Either the number continues the current sequence, or it starts a new one.
Right. Okay. Yeah. Sounds pretty reasonable. Does anybody else want to expand on that? Or if not, Robert, I'm happy for you to continue.
I didn't finish, but I was trying to do something where you would iterate through this list, and then if the next one in the list minus the current one in the list equaled 1, we would say they're consecutive, and if not, they are not. And then I was trying to figure out how to get the end slices, but.
Cool. Yeah. Okay, so to summarize our method so far between Robert and Audrey, we're going to scan through our list. You need to figure out a way of where's our stopping point in the list, in the consecutive. And so that probably is going to involve some sort of comparison between where you are and where you're going, or where you've been. Does anybody want to get some code out? What might our sort of starting code be?
I think first we need to sort that array to make sure it's sorted.
Mm-hmm.
And then we could say, okay, result is our empty list. Well, first of all, do we need to check if it's empty, this input?
It should just return nothing if it's empty.
Right, okay. But it's always better to check.
Yes, yes.
I was going to say that, okay, I would say set my A equals to the first element in the array, but if the array was empty, that would crash.
Yes, yeah, right. So yes, you could have a check if that was your strategy. Mm-hmm.
And then I would also say set previous equal to A. So first, first we sort the array. So you could say nums sort.
So you want to sort first?
Yes, because
wasn't the problem like the order matters? So if you sort them, then the order will be all messed up. Like you want to take a group of numbers that are all together, right?
Yeah. So I think that's a good point, Joyce, because if we, and sort of what Robert mentioned earlier, well, what I said to Robert earlier, if we had something like this, if we sorted it first, the 2s are going to be grouped together. So we're not going to be able to capture the 2 to 4 sequence and the 1 to 4 sequence if we sort first.
Okay, then let's not sort. I thought we needed to sort because in the output, the 99 is at the end, even though in the...
We will sort, we just won't sort first.
We'll sort the end, at the end? Okay, fine.
Yep. Okay, so how are we gonna scan and keep track of the two numbers that we're looking at?
Yeah, so I think we should set A to the array to the nums 0, and we set prev.
You say B?
Okay, well, fine. You want to be her? Okay. Equals to A.
Equals what? Sorry.
A.
Oh, equals to A.
Mm-hmm.
Okay.
And then for C in nums open brackets 1 colon, no brackets 1.
Yep.
And then colon.
Mm-hmm.
So we start with the second element.
Right. Okay.
And then colon.
Mm-hmm.
If C minus B is greater than 1. Okay, but I didn't consider this case if we could repeat, if we could go down again. So I guess we could also consider, okay, let's say if C minus B is greater than 1 or C is less than B. If we go down after that, yeah. Okay, in that case, oh yeah, sorry, I should have initialized the result as an empty list. Yeah. Okay, so in this case, the output append this, yeah, right, A and B. Mm-hmm. And then then A equals C and B equals C. Else B equals C. So basically my B is always the previous element when A is the start of the last interval. Okay, and after this loop is done, we also have output append AB for the very last.
Within the else loop?
No, after the loop.
Outside
here? Yeah.
Okay, what are you putting here, sorry?
The same as before, output append AB.
Okay.
Yeah, I think that's all, and then we return output.
Okay. Okay. Does anybody want to, shall we just try it, see what happens? Or does anyone want to comment now?
I tend to be a fan of parentheses, so I don't really trust expressions like that or there. I don't know if it'll.
Actually, is that does OR use does Python use a pipe for or is it just OR? I've actually just forgotten.
You can use a pipe if you want.
You can. Okay.
Well, I think the pipe is a bitwise OR.
Oh, it is. Okay.
Which should work fine for this.
I'm confused. Why are you saying A is C and then B is C? You're just redefining the same thing.
Because this would be the start of my next interval. So B is always my last element that I saw before I move to the next one. A is the start of the last interval, last range.
Right, but A equals C and then directly followed by B equals C. Mm-hmm. You could just really write B equals C because you're overriding A equals C by having it.
What? No, you're not overriding. In A, we will keep the last beginning of the consecutive streak. And B will
Oh,
be
I see, I see.
B will be changing as we go.
Okay, but then at the top, we could make just B equals nums 0, right? Because if A equals
Yes.
nums 0,
Yes, of
Okay.
course it's the same.
okay.
Yeah, and if we want to sort the output, then we may want to do it after we appended everything. I don't know. Does it know by default how to sort those tuples?
It does.
I'm not sure.
It sorts by the first element of the tuple. I don't think we clarified in the question how to treat it if the first one sorts differently than the second one. Like if you had one list that was 7,8 and another one that was 6,9.
Yeah.
This would sort 6,9 first, but we never really asked which was desired.
Yeah, so that would definitely be a clarifying question. For this particular problem, it's sorting by the first element of the tuple, each tuple. So the sorted would be appropriate for this one.
But if we have two different tuples with the same starting point, then
That would give us the second number to sort. It treats it like a nested sort.
Yeah.
Oh, okay, good.
Yeah. Well, let's give this a go, and we'll find out. Oh, I didn't do my test. Okay, that's the solution we're looking for. Did anybody have a different solution? I had a different solution.
I would like to see it.
I would first give others the opportunity before I present my solution. If anyone had anything different to this, or at least if you want to explain your algorithm, again, it's a good chance to practice how you would communicate your algorithms in a real interview.
I can share part of my solution with. It's not the full solution though. How do I do that?
Oh, are you sharing in? You mean share screen?
Yeah, I can do that.
Okay. Can you do it now that I've stopped?
Let me try.
Oh, I just realized there's a chat going on.
Is it enabled? Go to the security icon and do share screen.
Here, I'll change you to be the host.
Okay. Oops, sorry. So this is my list. Sorry, I zoomed in. I was trying to work with the fact that I wanted both the index and the content of a list. So I'm working with the enumerate sorted L. So first of all, I want to sort the list, and I also want to get the index. And here I'm printing the index, which is 0 to 8, the first. So I think this makes sense. Let me do this.
If you do enumerate, don't you have to have I and A, which is, or whatever, the element is arrays?
So when you do I enumerate, I'm getting the index and the content of the list that in as a tuple. So the 0th element would be 1.
No, when you do enumerate, then you get a couple of things. You get the index and the element.
Yeah,
But if you do it with just the I, it just has a tuple instead.
Okay.
I'm working with a tuple, yeah. Can you see the tuple?
Okay, sorry.
Yeah, so I'm working with a tuple. And then the pattern that I noticed is that if you take the difference of my element from the index for consecutive elements, that difference will be the same. And when I have another range of consecutive indexes, will be another difference and another difference and another difference. So then my challenge is to figure out what is the minimum, the maximum value from this list with the same difference blocks. And that's what I was trying to figure out. So element minus index, the difference would be the same. That means that they're consecutive.
Right.
Yeah.
And so you're saying if they have the same difference, then they're part of the same consecutive.
Exactly. And I'm just clear about the first and the last element there.
Right. It's interesting.
Yeah.
Okay. Post your, if you keep working on that after this, post your solution in the Slack. I'd love to see how you code that out. Oh, I've got another solution in the chat. Thanks, Essa. Thank you. Let me, that's a really cool solution, George. So, oops, whoopsie. Okay, so this one, can you pronounce your name for me again? Yeah, sorry, you're muted. Go again for me. I'm too scared to say it. You're muted. I'm gonna can I unmute you?
You can call it Asfetau.
Asfetau.
I know it's very challenging.
I'll practice it. This is Asfetau's solution. Thanks for sharing. Also, George, can you make me host again when you're ready? So do you want to explain your solution?
Yeah, of course it's not finished.
Mm-hmm.
I don't know, it's printing wrong solution. Now you can share us. You can copy this one and paste on your cell. So the approach is I sorted the elements,
mm-hmm.
Then I iterate from the first element until the last element.
Yep.
So if the difference is 1, if they are consecutive, so there is no appending. So
right.
Yeah. So the approach is stop when the sequence number is not coming. Then at that point, just will append the first and the last element of the sequence, the subsequence.
Mm-hmm. Mm-hmm.
So yeah, that was the approach, but I'm not receiving the full answer. I don't know, it's jumping to the elements 10 or 7 and 8. So you can show us the result, I don't know.
So B is the output?
Yeah, you can see the output. Yeah, it's showing, so partly is fine, but it's not working for all elements.
Okay, so some debugging on that one. Audrey just said in the chat, I noticed, oh, I just realized I'm not showing my screen anymore. I have been doing stuff on the screen as if I was sharing, sorry. Okay, here is the solution here. So the output is here, so you can see, yeah, we're not getting the 7, 8. So some debugging on this one. And Audrey did just say in the chat, if you can share your solutions in the Slack so that people can play around with them and maybe debug them. I think debugging other people's solutions is always a good exercise. Another approach, you're thinking about the difference again, sort of like what George was thinking of, thinking about the difference between the consecutives. I like that approach. Okay, well, I'll share my solution. And I came up with, through 2 decent solutions. My third one I didn't like as much, but I came up with 2 solutions as well, and this was the one I liked better. So play around with them. So the way I was thinking about this one, oh, I had some hints. The way I was thinking about this one was to have 2 pointers. And essentially the algorithm here is that when we're going to have essentially 2 scanners. One scanner is going to scan scan everything, and the other one is going to scan the consecutive blocks. So I decided to have 2 pointers, an I and a J, and the I and J are going to first start at the first element here together, and then I obviously initialize my output, and then I did a while loop. So while our J index is less than the length of the list, then, and actually I think you might want that to be less equal, then I'm going to check to see if the J is equal to the length of the list minus 1, because if it is, that means we're at the end of the list. So we are going to want to append our our items at our I and j pointers straight away, and that's what we're going to return. So we're actually going to check if we're at the end. So that would accommodate the empty list scenario as well. If j is equal to the length of list minus 1, if the length of the list is 0, minus 1, might need to check on that one. It was meant to account for the empty case. So let me think about that further. But you're going to return straight away. If it's not though, the next thing I'm going to check is that if the item at index j plus 1 is equal to the jth plus 1 item, then we're going to just iterate our pointer, our j pointer. Otherwise, if it's not equal, we're going to append our I and our j. So I is always the beginning, the outside loop. It's the beginning of our consecutive, and the j is the thing that checks, is it a part of a consecutive? So is the moment that it's not part of this consecutive, it appends the I and j element. And then we're going to increase both I and j. So now we're starting together again at the next consecutive. And then this will take us back to the start of the loop. It'll check if we're at the end. If we're at the end, it'll output straight away. If we're not at the end, then we're going to check, is the next element, the next one up, are they equal? If they are, then we're going to keep moving the jth element across. And the moment that the jth element is not one more than the j plus 1 element, we're going to move the I and j starter to the next starting point of the element. If that makes sense. So, oh yes, here's where I put my check in. You could have it checked to see if it's an empty and say there are no consecutives. So you could put a more meaningful output in that scenario. So this was my final solution, and this is my solution with the empty list. So I was thinking about it in a while loop and having 2 pointers, scanning the whole list and then scanning the list of consecutives. Any questions on that one? That was my approach. A bit different to some of the...
Yeah, I think this is very good. Basically, you are just, it's similar to what I did, but you are keeping indices instead of values. So yeah. Your I is the index of my A and your J is the index of my B.
Exactly.
That's fine. And you don't want to do this in the loop. You check every time that J is equal to length of nums minus 1. You can just end your loop one earlier, and then at the end you just do this last part.
Do you mean you don't need this if statement, you just have these two?
You can just have your while loop ending one earlier, so length of nums minus 1. And then...
Oh, you mean put this in the while statement?
Yeah, and then this last one you just append at the end, I think. Okay, let me see. Or will we...
Yeah, let me come over. So you're thinking, oh, don't want to actually play that. So you're thinking in the while loop here.
No, maybe I'm wrong.
Because the reason why I had to put this in is because before I put it in, it was cutting off, because it gets to a point where it gets out of range, where the jth element increments and then it's out of the index limit, and so it doesn't end up, it either returns an error or it doesn't return the last pair because it runs out.
Right. No, you are already comparing this next element with the current one, so you can just end the while loop one before, so until len of nums minus 1.
Here.
And then then you just, after the loop, you append the last one.
Right. So essentially taking this outside, is that what you're saying?
Yeah.
Let's try it.
And remove that if.
Yeah. Okay. Yeah, nice.
One question.
Yes.
Yeah, I think I wonder why you are not using a sorted function before you go to while loop. For example, if you test this solution by exchanging the position of 7 after 4 at index 4.
Mm-hmm.
Yeah, can we see the result?
Do you mean if we have that and not this?
Yeah, put 4. Still, you need to have 4.
4 here?
Yes.
Like that?
Yes.
Yep.
So do we?
So
that will give a different result.
So
Yeah,
one of the requirements of the question was that it wants to identify the consecutives that are given in a list. So in this scenario, it doesn't want you to sort it first because it wants the assumption in this question is that you're given a list with a bunch of consecutive chunks in it, and it wants you to find the consecutive chunks. So if you sorted it, you're not going to be able to identify the chunks because you might have a scenario where you have the 2, 3, 4. And so you would want this to output, well, you'd want it to output this, the 1 to 4 chunk, and then the 2 to 4 chunk. But if you sorted it, you would get those, all of the single chunks that you would get. So you would have the, all of these little consecutives. But for this particular question, and this would be part of the clarifying questions that you ask the interviewer, would be exactly this. Do you want it to find all of the consecutives once it's in order, or do you want it to find the chunk of the consecutives in the list that's given? In this scenario, we want to find the chunks of consecutives. So that's why you wouldn't sort first. For this question, a different question, this solution would apply. Yeah.
Okay. Okay. Thank you.
Yeah. Thanks. So there are quite a few solutions here, and they are pretty similar. Both George and Svetlana have come up with the sort of thinking about the difference, and then Svetlana and I have been thinking about the loops, which obviously you've done loops here as well. So if you want to share your solutions in the Slack group for everyone to have a look and study them and debug them, and also I would think about your edge cases for this one. So as always, I do some takeaways. So for this one, my solution involved pointers, and I think any question that involves scanning through a list, think about what are you trying to point at with your INJ indexes? What is it that you need to compare with each other? What needs to look at what needs to be compared with what? And then while loops or for loops, one thing with while loops, make sure they're not infinite loops and that you do actually have a breaking point. Check for your edge cases for where you're going to return. And then your return is an ordered set of tuples for this particular question. For my solution, it's a linear time space. So for some of the other solutions, think about what your time space complexity is going to be. I would love to know if anyone can come up with a log solution for this. I'm not sure. I couldn't think of one. And then you can think about returning.
Probably need to read all the numbers. So
what was that? Sorry.
I think it takes linear time just to read all the numbers. So
yeah. In your worst case, exactly.
So that's a lower bound right there.
Yeah, yeah. So I don't think it wouldn't be possible to have a log solution. And then my last point was just to think about output for your edge cases. Think about putting meaningful strings if it is an empty list, or error handling. Not really relevant for an algorithmics question like this, but just general coding practices if you want to think about error handling. Or if thinking about if someone was to input a list of strings or something like that, how would it handle that? Cool. All right. Well, we'll move on to my final one. Whoa, time really got away. Got a couple of resources here. I'll share the notebook that has this question, that Colab notebook. some cheat sheets on Big O and some crash, a Python crash course for anyone who wants to brush up on that. Okay, so our statistics questions today is, given X and Y both have a uniform distribution with mean 0 and standard deviation 1, what is the probability of 2X being greater than Y? Some of you have probably come across this question before. And there are sort of two approaches to this question. You can, sort of the more math heavy response, and you can also do a more logic reasoned approach to this. So have a think, write down your thoughts. I do have some hints, which I'll give you a minute to think about it on your own, and then I'll sort of go through some of my hint slides that I have if you're stuck.
I'm sorry, what do you mean by uniform distribution with mean 0 and standard deviation 1? Mean and standard deviation, are they not usually for normal distribution?
Yeah, so both.
Uniform distribution is usually on a certain interval, not with, I mean, well, I guess there is a mean, but.
Yeah, so they do have a mean that's going to be their central point. And you do bring up an interesting quirk to this question. The standard deviation isn't as relevant for this one.
For uniform distribution, you specify some kind of interval.
Correct. So in this case, it's going to be centered around 0.
Okay.
I mean, I guess technically the problem as written is well specified. There exists a uniform distribution with a standard deviation of 1. It just has a length different than 1.
Yeah, I guess.
Yeah, so I guess my hint for this question is that the solution is actually the same no matter what your standard deviation is my hint for this question, my first hint. I'll move through some of my hint slides just for anyone who wants a refresher on uniform distributions. I'm going to preface this by saying I did this really late at night and I did these graphs by hand, so please be gentle.
One clarifying question that should be asked is, are they correlated or associated, or are they independent draws?
They're independent. Yeah, good question. So we do have two variables, the X and Y, but just to clarify on uniform distribution in the single variate case. In this scenario, like we said, we do with the mean 0, it means there is equal probability no matter the value of X. So this is essentially what our PDF looks like in a uniform distribution. And typically it's between some value A and B, like Svetlana was saying. In this case, because we're centered around 0, it's going to be, our bounds are -A to A. So this is what we're looking at. The probability of something in a uniform, in anything really, is the area under the curve of the PDF, the probability density function. So for more complex distributions for continuous variables, this usually means taking integrals of the PDF to find the CDF. But in this case, as you can see, with the uniform distribution, it's really nice. It's just a rectangle. So our area under the curve is just going to be length times height. So it actually makes our job a little bit easier to find probabilities in this case. So in this scenario, our length here, if we're thinking about what the probability is going to be, our length of the whole distribution is 2A for both of these sections. And then we've got to figure out what the height is. And we know that if this is the complete distribution and the event space, that the event of everything happening is going to be 1. So we know that we know that the area under this curve is going to be 1. So in that case, we can work backwards to find both A, and we can also find H. So, or H, I should say. We are told that we have a standard deviation of 1, and the formula for a standard deviation for the uniform distribution is B minus A divided by square root of 12. We won't derive that here. I'll give you some resources if you want to look up the derivation of this. So in this case, and again, like I mentioned earlier, the standard deviation doesn't actually matter, but we're going to use the standard deviation that they gave us, which was 1. So again, we can work backwards to solve for what our A value is. So in this case, B is this number, and A that we have over here is negative A. So we've got A minus negative A is going to become 2A, dividing by that square root of 12. And then when we factor out our 4, we find that our A is actually going to be square root of 3. So now we have that our bounds in this scenario is negative square root 3 to 3, square root 3. And our length is 2 square root 3. And with that, that means we can find H. So we have H is equal to 1 on 2 square root 3. And we can check that that is indeed the case. When we multiply length by height, we do in fact get 1, which is exactly what we want. So that's our sanity check. So, well, actually, I won't reveal the solution just yet. That's kind of crash course on how we're calculating probabilities in a uniform solution. At least the mathematical approach. You could have a reasoned approach. Does anybody want to jump in and touch on our problem where we have two variables, our x and y, where 2x is probability of 2x being greater than y? And you don't have to use the mathematical language if you don't want to.
For any x and y that one could draw from the distribution, you're equally likely to get x comma y, or x comma minus y, or minus x comma y, or minus x comma minus y. Mm-hmm. And you should be able to show that no matter which one of that, for that set of 4, you always have 2 of them in which 2x is greater than y, and 2 of them in which 2x is less than y. Mm-hmm. Ignoring the equality case, because that's a vanishing probability.
Mm-hmm. And so with that case, given that you've got two scenarios, what is your conclusion of what the probability would be?
So given that, you're concluding by symmetry that the probability is 1/2.
I will reveal that the correct probability is 1/2. Exactly. Yeah. Yeah. And that's and you're essentially iterating, and you know, in a interview format where you potentially aren't able to draw graphs, or you don't want to go, that would probably be the best way to reason through it. Just to circle back to the interview scenario, it's going through all of your combinations that are possible, and the are they I said odd and even, are they negative and positive, and what are your possible scenarios as far as x being greater than y. I
was thinking that another way one could do it is take the distribution that we just calculated here. You don't really even need this standard deviation, just leave it in terms of A, and then find what the distribution of the quantity 2x minus y is, and you can show that it's still centered on 0.
And there was a resource I found this week that had some R code where you can actually prove that if you're someone who likes to play around and you're not convinced that the value of A doesn't matter in this scenario, there's some scripts where you can play around and see that you get the same result every time. And there are a bunch of proofs online as well. But yes, it is actually even just nicer to keep it as A, just reading wise, but just to sort of show you that the logic works out to equal 1 if you like to see the numbers. But yeah, I guess the trick in this problem is that the standard deviation didn't matter. So I will, anyone else before I sort of reveal my next slide?
So should we look at distribution for 2x? I guess it will be wider and lower, right?
It'll be what, sorry?
The probability distribution for 2x would be between -2 square root of 3 to 2 square root of 3, and the height will be 1/2 of this height.
So will that change the probability being 1/2?
No, maybe. Probably not. Okay, please show what you have.
No, so you bring up a really good point. So I guess, and again, you probably won't have the resource to be able to demonstrate like this in an interview, but if we think about having a uniform distributions x down here, y down here, again, the bounding values of a doesn't matter. In this scenario, this author has done 1.5. I gave up drawing my own graphs and I stole someone else's graph last night when I got fed up. So it actually doesn't matter, but we're bounding x and y in the same boundaries from, in this case, -1.5 to 1.5 here and here. And now if we bound it by our a values and then we draw the line of y equals 2x, which we can verify that this is, if we go to x is equal to 1/2, we would expect y to equal 1, which it does. So our line here, and as we saw earlier in the single variate case, the probability is the area under the curve. And in this case, our curve is the line y equals 2x. Now we're trying to find the probability of 2x being greater than y. So when we have our curve or our line of y equals 2x, we want to find all of the space where 2x is greater than y. If we were doing less than, we'd be on this half of the graph. And just thinking about it, again, this can seem a little hand wavy, but you can actually see that this does cut our boundary box directly in half. It is directly symmetrical. So we could figure out what these values are and calculate this area, and we could take integrals and do all this kind of stuff. But as far as eyeballing it goes, we can see that the probability is indeed 1/2. The area under this line here within this bounding box is 1/2. And then if you, just to sort of take home the fact that a doesn't matter, if we think about a being 0.5, our bounding box in this scenario would go to 0.5, 0.5. Our bounding box would look like this. And you can see the line y equals 2x still cuts that box in half. So no matter the value, if the value was 1, the probability is always going to be 1/2, because and this is especially the case because we're centered on 0, so we are symmetrical in this particular scenario.
This visualization is a useful visual for the argument that I was making as well, where I was just basically saying that the 4 corners of the bounding box are, for any given bounding box, 2 of the corners will be in the shaded region and 2 will not.
Right, precisely. And you can see that here. You've got this small slither here, this colored slither here, and then the bigger slither and the colored slither, and then exactly symmetrical. And then so that, I guess that's solution 1, the mathematical thinking of it. And again, sorry, I was going to say, if we thought about the scenario, this is maybe getting into a little bit much, but if we thought about the probability of x2 being greater than or equal to y, how would that change in this scenario, if at all?
What is the new question?
If we were trying to find the probability of 2x being greater than or equal to y.
I mean, equality in probabilities doesn't change anything, right? Because this is a continuous distribution. So probability of a single event is 0.
Right.
So I'd say it would be the same answer, half.
And you can think the visualization, perhaps this line would be a dotted line rather than a solid line. Well, in fact, in this case, it probably should be a dotted line. But yeah, in the continuous case, it shouldn't make a difference on the probability.
I have a question for you though. Using this visualization as argument to show that that is half, by that same argument, then the probability of x being greater than y is also half.
Exactly. So it actually doesn't matter what your line is, because you can think about drawing, you can think about drawing the line y equals x, which would look like this, and
Okay.
that's exactly the same.
Oh,
And
it gets more sorry.
no, you go.
Then it gets more interesting. Okay, well, what about the probability of 3x greater than y?
Then we have something steeper.
So anything ax is greater than y is half?
In the scenario where they both have the uniform distribution centered around 0, yes.
Okay.
Because if that equals negative x, well then you're going to have, your line's going to cut in the opposite direction.
Yeah.
So it's a good visual because you can play around with moving the line.
That's counterintuitive because usually when you let's say you pick the probability of 100x greater than y and they have the same probability, you don't think it would be half.
Right. And that's because your 100 is just your scalar constant, so it shouldn't have an impact on the probability.
I don't know, it's counterintuitive for me because x and y, if you draw them, you get some value, but then you multiply x by 100.
Right.
But it can come on the other side. That's the problem. It's symmetric. That's why.
And I think this more reasoned approach. So the solution 2 is, and I found this question on a bunch of places. I also found it on Interview Query, and they didn't do any kind of sort of mathematical or logical thinking in it. This was essentially their solution, where they ran through all the possible scenarios, and then they reasoned through, they determined which scenarios are still true when 2x is greater than y, or even, like we said, x is greater than y. And they found that 3 out of the 6 scenarios were still true. So by that logic, half. The probability of this scenario happening is a half. So I guess that is your, it's a little bit hand wavy, but I don't think in an interview you're able to, draw up your integrals or draw up your graphs and that kind of thing. So perhaps in an interview scenario, they are looking for a more reasoned approach that you're thinking about where it's lying. But I wanted to provide you both solutions so that if those people, you can choose which one resonates with you more. Any questions on this solution? Or the way this is presented?
Yeah, so do they mean like if it could be true or not, then that's still considered like not true, because for the third scenario, if x is less than y, that doesn't really imply that 2x is not less than y, or 2x is bigger than y. Like both scenarios are possible, I think.
Right, so out of these, yeah, exactly. So out of these 6 scenarios, when we apply our scenario of 2x, do these still hold up? And you can also think of these scenarios in the quadrants as well. Like we were saying, you've got x and y both positive, y positive, x negative, y positive, and think about where those points lie on this curve. So if you are a visual person, or you can visualize curves or lines on a graph, you can sort of think about where these are sitting, and that can help the truth. But in this scenario, you're right, it is more hand wavy because there are the scenarios where either could be the case, doesn't, or it's not guaranteed.
Okay.
Can I extend this question? This is interesting. So I think this would be the same case, that probability of ax greater than y is half for any symmetrical distribution around 0 then. It doesn't have to be uniform, right? So it could be normal.
Mm-hmm.
It could be anything that's symmetric around 0.
Yeah,
They
exactly.
don't even have to be the same distribution. You could have one of them be normal and the other one could be uniform.
That's version 3. Okay. That's are you sure about that?
As long as they're both symmetric, as long as the distribution of x is symmetric about 0 and the distribution of y is symmetric about 0, then the distribution of 2x is also symmetric about 0, and the distribution of 2x minus y, any linear combination of those two distributions, is going to also be symmetric about 0.
Perfect, perfect. So let's find a case where that's not the case. We have to do some kind of nonlinear function, right? So x squared probably greater than y.
Yeah, that's going to be a different problem.
Aha. So we need a neural network, you're saying, Robert, because it's nonlinear, right? Thank you.
George, you always want to try and find how you can.
I'm trying to find a reason to use neural networks.
Yeah. Oh, funny. You'll have to do a deep dive in DLA. I wrote these takeaways up really late at night again, so they're not the most meaningful takeaways, but testing some knowledge on your distributions, how to calculate probabilities, or at least understanding sort of area under the PDF curves, perhaps even testing understanding of variance and what's the E?
Either expectation or expected value, I think.
Expected value, that's what I'm looking for, thanks. Expected value. And then I have a couple of resources here for anyone who wants to check up on this one. This question is literally everywhere. It is kind of a 101 stack question. Stack Exchange gives some a more mathematical solution. They go through some of the integrals and they give some follow-on questions. Interview Query gives the sort of less formal solution that's more reasoned, like we spoke about. There's a link here to a refresher on the uniform distribution, just in the single variate case. More discussions on this particular problem are on Quora that I found. And then, of course, Khan Academy always has some helpful go-to videos.
George. One last question. I know we talked about continuous variables here, but what things would you take into consideration if this was a discrete random variable?
I will actually point you to this one. This link here on uniform distribution actually talks about that case, the scenario. Talks about the discrete scenario.
Because I'm sure there are some combinations that don't make sense. There are some invalid combinations.
Yeah, so
there you go.
There you go, right there. So I guess your scenario in this is, yeah, okay, they give you the die roll example I was about to say, like a die roll. So your location parameter, did they just skip over it or did I?
Okay, that's interesting.
Right, so, yeah, okay, so you're going to have a finite amount of, so your probabilities are still going to be the same. I guess, are you talking about if you're thinking about a range of variabilities? So if you wanted to know the probability of something less than a 3 being rolled, sort of that scenario. So then, you would look at the CDFs for discrete.
Yeah, but if you have discrete distribution, right, there's only specific values that X can take, cannot take any value.
Yep.
Okay.
Yep.
Well, in this case, I don't think the probability would change. I think it would still be half, but I'm curious what is different if it's a PMF versus a PDF.
Yeah. Anybody want to chime in?
I think we should calm down, Audrey. Audrey, you're doing well.
I'm just in the chat freaking out a little bit. It's fine.
Is there a chat? I can never see the chat as host. They need to make that more accessible. Oh yeah, well, you know, I'm done with my questions, so we can circle back to some more discussion.